Guys, welcome back. So today we are gonna focus our energy on how to add and subtract rational expressions. But before we do that, let's go ahead do something from back in the days, from our preschool days. So suppose I asked you to say quick add 1/5 and 2/5. Okay. So the question is, how do we add or subtract fractions? Or you want to impress your friends? How do we add or subtract rational numbers? To add or subtract fractions, we pretty much, one, have to make sure that the denominators are the same. And then two, if they are, then we can proceed to either add or subtract depending on the operation. In this case, we are adding two fractions that have the same denominator, so let's go ahead and do this. So we're going to add the numerators, namely 1 and 2, to make 3, and then write the sum over the common denominator. And then we just ask ourselves, is this problem reduced? And the answer is yes. Now, let's just say we had another problem, say 1/5, let's call this B, 1/5 minus 2/5. So I'm looking at this problem and I'm like, okay, do I have the green light to go? And the answer is yes. Why? Because the denominators are the same. So let's do this. To subtract two fractions that have the same denominator, we're going to subtract the numerators and write the difference over the common denominator. Difference of 1 and 2 is -1, and then we write the difference over 5 and then reduce. Okay, now problem C, we have 1/3 plus 1/2. Unfortunately, we can't just add right now because the denominators are not the same. So if I have some thirds and then you give me a half, I'm like, how many thirds do I have? I'm like, I don't know. Okay, it's not really easy for me to see. So when we are adding or subtracting numbers, we need to make sure that the denominators are the same. If they're not, then fix it. So our first goal is to find the LCD, which in this case is 6, and then we're going to take our time to write those equivalent fractions. So in English, fix it so each denominator looks like the LCD just found. This 3 is missing a factor of 2, and when we give it to it, we are going to tell the world that 1/3 is the same as 2/6. So one equivalent fraction down, one more to go. The second rational expression, rational number or fraction, okay? To make this 2 look like the LCD of 6, let's give it the missing factor of 3. And then we're going to tell the world that 1/2 is the same as 3/6. Thanks to our hard work, now that the denominators are the same, we have green light to proceed. So now that we are adding two fractions that have the same denominator, let's add the numerators and write the sum over the common denominator. Sum of 2 and 3 is 5, and then we write that over the common denominator of 6. Of course, these problems are not going to be on the test. These bonus problems, we do these problems to as a warm-up to what we're actually going to do, or as a warm-up to what we are going to be assessed on. Yeah, remind me not to speak so much. So now the question is, so we did a quick review on how to add or subtract regular fractions, but now the question is, how do we add or subtract rational expressions? We are going to add or subtract the same exact way. So we have P and Q represent polynomials, so we have rational expression, and then we're going to add to it another rational expression. How do we add two rational expressions? Same way as we do our regular fractions, okay? We're going to add the numerators. Sorry, I'm having a moment. We're going to add the numerators and then write the sum over a common denominator. Now, what if we had a subtraction problem? What if we were subtracting two rational expressions that had the same denominator? Okay, well, then we have to it, okay? We're going to subtract the numerators and then write the difference over the common denominator. Now, the question is, what if we were subtracting two rational expressions that didn't have the same denominator? How are we going to handle it? Well, if you could handle A, B, and C, any problem from this section, it's going to be the same thing. If you're adding or subtracting two rational expressions that have different denominators, your first goal is to find the LCD, and then your second goal is to fix it so each denominator looks like the LCD just found. And then 3, handle it, add or subtract as indicated. And as always, because we have fractions or rational expressions, we need to make sure that our answer is reduced. Okay, so for these fun problems, we have 5 on the agenda. Some may have the same denominator, some may not. So let's do this so we can be out. Okay, so it says perform the indicated operation. So that's code for do whatever that operation says. We got a plus sign, so guess what? We are adding. So the first question I'm going to ask myself is, are the denominators the same? Let me cross my fingers. So are they the same? And the answer is yes. So that makes me happy. Because the denominators are the same, then we have the green light to add right now. How are we going to do that? We're going to add the numerators and then write the sum over the common denominator. Okay, so the first numerator reads 3x squared plus 15x, and then we are going to add to it the second numerator. Okay, so we're going to add to it the second numerator, which is 2x squared plus 5x. Someone asked me, Miss Doris, oh, my name, I'm supposed to be like a secret. All right. So someone asked me, do we have to put parentheses around the second numerator? And the answer is no. Okay, why not? Well, that's because the addition sign doesn't affect the value of the terms that follow it. So parentheses are not needed. Okay, so again, how do we add two rational expressions that have the same denominator? We're going to add the numerators and then write the sum over the common denominator. So like add and keep the bottom. Okay, so that will give us x cubed plus 2x squared minus 8x. Fantastic. So let's take our time, simplify the numerator, and then we'll ask ourselves, is this bad or reduced? Okay, looking at the squared terms, namely 3x squared and 2x squared, and that will simplify to 5x squared. When we combine the regular x's, 15x plus 5x will give us 20x, and that's all over the denominator. Okay, give me a moment. So the question that I'm going to ask myself, is it reduced? Okay, when it comes to regular fractions or rational expressions, it's implied that you always reduce or simplify to lowest terms. The directions may not remind you, hey, reduce it. That's something you're going to have in the back of your mind. You reduce it however you want. Okay, so when it comes to reducing rational expressions, remember, we need to factor everything. Factor the top, factor the bottom, and take it from there. With your permission, I'm going to go ahead and number these 1 and 2. Why? Because it's hard for me to factor mentally, so I'm going to just do this on the side. Okay, so first polynomial, or whatever I labeled number 1, we have 5x squared plus 20x, and then I'm going to have all the space in the world to factor. Prerequisite step when it comes to factoring is to watch out for common factors. 5x squared and 20x have a common factor of 5x, so let's do this. When we factor it from the expression, that will leave us with x plus 4, and if you're having a moment, distribute right now and then you're good to go. So one polynomial down, one more to go. So number 2, I need like a little break. Okay, so we have x cubed plus 2x squared minus 8x. Prerequisite step, watch out for common factors. So in this case, the GCF is x. Let's go ahead, factor it, and that will give us x squared plus 2x minus 8. Fantastic. So moving forward, so what kind of polynomial do I have left with? I got a 3-term expression or trinomial. Share that with your friends. When it comes to trinomials, I'm always going to cross my fingers and ask myself, is the leading coefficient 1? I hope so, so that way we don't have to use the AC method. But if you want to use the AC method, go for it. In this case, we don't have to. Let's go ahead, throw down parentheses, focus on getting the first term. The product of the first term should give us x squared, so we're always going to use variable times itself. To complete the binomial factors, you want factors of c that add up to b. Factors of -8 that add up to 2. If I know how to count, I think it's 4 and 2, where the larger factor is positive. So that means that the smaller factor is negative. If you want to do the escape, then go for it. But if you don't need the escape, then I don't need it. It's really a personal choice. Okay, hopefully I did it right. Well, let me check it now that I wrote it. Product of 4 and -2 is -8. Sum of 4 and -2 is 2. Okay, cool. So we checked it. Let's bring down the GCF. So I think we factored completely. Let's go ahead, back to our solution, and then write the numerator and denominator in factored form. So the numerator, thanks to our hard work, and when we factor it completely, gives us 5x times x plus 4, and that's all over. The denominator in factored form is x times x plus 4 times x minus 2. Fantastic. So again, the toughest part about simplifying or reducing rational expressions is the factoring part. Once you got that, it's like you can breathe if you weren't breathing already. Okay, so let's go ahead and reduce. So for me, I just look at the denominator and then I slide across and see if I could cancel with something. So I have an x. I want to know, is there a factor of x that I can cancel it with? And the answer is yes. Let's go ahead and do that. Okay, I circled it because the slash kind of blends in with the x. I got an x plus 4. Can I cancel it with something else? I sure can. Okay, I got an x minus 2. Can I cancel it with something else? Unfortunately, I cannot. Okay, so that's our answer. In the numerator, we have product of 5 and lots of 1, so it's just 5. In the denominator, we have product of 1s and an x minus 2, or just x minus 2. Someone asked me, do we need parentheses around the x minus 2? No, it's no longer being multiplied by anything other than 1. Someone asked me, is it okay if we put them? Yeah, you can put them, but I guess the question that you want to ask is, will you get dinged? Yeah, okay. Your answers need to be as clean cut as possible. Okay, so that is our first problem. So let's go ahead and knock out our second problem. Give me a sec. Okay, so problem number 2 or B has been identified. If you are taking notes, you can pause it right now, write the problem, and then once you're done writing it, then you can hit resume or play, whatever I'm trying to say. Okay, so we have two rational expressions separated by a minus sign. So in this case, we are subtracting. So the first question that I'm going to ask myself is this: are the denominators the same? I hope so, and the answer is yes. So because the denominators are the same, we can begin to subtract right now. Okay, so to do that, we are going to subtract the numerators and then write the difference over the common denominator. So let's do this. So the first numerator reads 20x squared plus 5x plus 1, and we're going to subtract from it the second numerator. Bear in mind that unlike addition, the subtraction will affect the value of anything that follows it. So the popular mistake is that students sometimes fail to put parentheses. So go ahead, write that open parenthesis, and then with confidence write the second numerator. And then if we have an open parenthesis, we got to close that door. So put that closed parenthesis. So we successfully subtracted the numerators. Now we're going to take our time and write the difference over the common denominator. Okay, which is 6x squared plus x minus 2. Let's clean up the top and then ask ourselves, is this bad boy reduced? Alright, so we're going to copy the first three terms as is. So we have 20x squared plus 5x plus 1, and then you handle the subtraction sign however you like. For me, I just like to say the rule for subtraction. We're going to add the opposite, but if you want to say distribute the negative, no one will ever know. Okay, we're going to write the same exact thing. So when we add the opposite of a positive term is a negative term. Opposite of subtracting 12x is adding 12x. Opposite of subtracting 5 is adding 5. So fantastic, we got this. So for this section, we're pretty much combining, adding, and subtracting polynomials, and then we are combining the factoring unit and all that good stuff. Okay, so let's go ahead, clean up the numerator. When we combine like terms, the sum of the squared terms, so 20x squared minus 8x squared, I believe gives us 12x squared. When we combine the x's, 5x plus 12x will give us 17x. And when we combine the constants, namely 1 and 5, that will give us 6. Fantastic. So numerator has been simplified. Let's go ahead and do this. For the denominator, we just copy it over. So the million-dollar question is this bad boy reduced? I really don't know. Okay, for me it's hard to factor in my head, so I'm gonna go ahead and number these polynomials. So I'm gonna number the numerator and denominator and then show all my work on the side. Okay, so let me have like a, oh, I think it's fine. Okay, I'm gonna go ahead, write number 1, and then we have 12x squared plus 17x plus 6, and then you factor however your heart desires. So let me zoom in. I think I could zoom in more. Okay, cool. So prerequisite step is to watch out for common factors. So in this case, there's no GCF to yank out. We got a trinomial. I'm always asking myself, is the leading coefficient 1? And the answer is no. So we're going to go ahead and use the X game. I'm running out of space. I'm going to do the X game below. So if we use I'm not sure if I said that right. So the leading coefficient is not 1, so we are going to use the AC method to factor. That's what I was supposed to say, okay? So the corresponding X game, we want factors of AC that add up to B. So factors of A times C that add up to B. So in this case, we want factors of 12 times 6, which is 72, that add up to B, or 17. So I think it's 9 and 8. Let's check it. Product of 9 and 8 may be 72. Sum of 9 and 8 is definitely 17. Okay, so if you have a calculator, check me on it. Okay, so we are going to split the middle term by replacing it with 9x and 8x. So let's do this. So that will give us 12x squared. 9x is positive, so we're going to put plus 9x. 8x is also positive, so plus 8x. And then we bring down that plus 6. Now that we successfully split the middle term into two terms, let's go ahead factor by grouping. So we'll group the first two, group the last two. We checked our X game, so we know that we shouldn't have any surprises like, oh man, I made a mistake. Looking at the first binomial, the GCF in this case is 3x. When we factor it out, that will leave you with 4x plus 3. For the second group, the GCF is 2. When we take our time and factor it out, that will leave us with 4x plus 3. Fantastic. So at this point, we are going to factor out the common binomial of 4x plus 3. Let's do this. When we factor it out from the expression, that will leave us with first product over common factor. The binomials cancel out, and that will leave you with 3x. Second product over common factor, the binomials cancel out, and that will leave you with 2. Okay, so one polynomial down, one more to go. So no, I need like a break, okay, like a real break, but in this case a visual break. Second polynomial, we have 6x squared plus x minus 2, and let's just go straight to the punchline. Okay, so in this case, the leading coefficient is not 1, so we're going to use the AC method to factor. So I'm going to do the X game on the side. So we want factors of AC that add up to B. Factors of A times C that add up to B. Product of A and C will give us negative 12. Value of B is positive 1. So we need factors of negative 12 that add up to 1. So in this case, I believe 4 and 3 is the winner. The sum should be positive, so the larger factor should be positive. So let's check it. Product is negative 12, sum is 1, so we're good. Let's go ahead split that middle term. Remember, we always use the variable part of the middle term because we're trying to split the middle term, not like the first term. Okay, so that will leave us with 6x squared plus 4x minus 3. We bring down the rest of the problem, minus 2. Let's go ahead, take it from here. Let's make our groups of 2. Okay, I think I'm missing something. Yeah, the x. Remind me to copy things correctly. From the first group, 6x squared and 4x have a common factor of 2x. So let's do this. When we factor out a 2x, that will leave us with 3x plus 2. So one group down, one more to go. From the second group, 3x and 2 have no factors in common other than 1. So I guess the GCF is 1. But again, we want to start on a positive note after we take out a common factor. We want the first thing to be positive. Who cares if the rest are negative? When we factor out a negative 1, first term over common factor will leave us with 3x. Second term over common factor will leave us with 2. So as expected, the binomial factors match. So let's go ahead factor out our new GCF. Okay, I factor out the common binomial. When we factor out the binomial of 3x plus 2, let's show the reader what we're left with. First product over common binomial, over GCF, the binomials cancel out, and that leaves us with 2x. Second product, when we divide it by GCF, the binomials cancel out, and that will leave us with -1. So we did it, guys. Oh, took us forever, but it's okay. We did it. Okay. Thanks to our hard work, the numerator factored completely to 4x plus 3 times 3x plus 2. And that's all over the common denominator of 3x plus 2 times 2x minus 1. Okay, so again, when it comes to reducing rational expressions, the toughest part is factoring, but we already did it. So let's ask ourselves, is this reduced? I don't know. I have a 3x plus 2. Can I cancel it with something? I sure can. So let's go ahead and do it. I got a 2x minus 1. Can I cancel it with something? Nope. Okay, so I think that's it. In the numerator, we have a 4x plus 3. In the denominator, we have 2x minus 1. Okay, my agenda was to do a total of 5 problems, but I think we're going to table the 3 problems in the next vid. For this video, I guess we end up focusing on how to add or subtract rational expressions that have the same denominator. In the next video, we are going to focus our energy on how to add or subtract rational expressions that, you guessed it, have different denominators. So bear with me. Thanks.